Hi, and welcome to class time. It's time for math, and as usual, you can watch this lesson in real time on Televisions Jamaica's YouTube channel or One Spot Media. I am Brittany Henderson.
And I am Wadian Price. And today we'll be looking at making inferences from statistics.
All right, so let's get started. So our objective for today is to make inferences from statistics, raw data, tables, diagrams, and summary statistics. Now, Mr. Price, what is an inference?
Well, an inference is a conclusion reached based on evidence and reasoning.
Okay, so there's some investigation that takes place. Okay. And today in particular, we're looking at statistical inferences. So statistical inferences consist of the use of statistics to draw conclusions about some unknown aspect of a population based on a random sample from that population.
Definitely.
All right. So we're investigating some things today.
Right.
All right, raw data. A lot of you have come across raw data in your investigations in doing statistics, right? What is that?
Well, raw data is simply data that was collected but not sorted, grouped, or processed. So it's like uncooked data.
Okay, so it's uncooked.
Yeah,
so if
raw.
I went into a class, for example, right? And I just asked for the heights of students in the class. So I collect all the heights of those students. That would be my raw data, the uncooked data.
Definitely.
All right. And here you see we have some examples of raw data. So we just have some numbers here. It can mean anything. So we have an example here.
All right, so in terms of summary statistics, this is information that gives a quick and simple description of the data, which includes mean, median, mode, minimum value, maximum value, range, standard deviation, etc. And here we have an example. So what we are seeing in the table here, it depicts the height of corn plants that were measured over a 13-day period, and it is recorded in the table as we are seeing it here. Now, what can you ascertain from this table?
Okay, so I know that on day 1, the height of the corn plant was 6.2 centimeters. But by day 13, it grew somewhat. It grew to 7.3 centimeters. So from this table, I can see that. I can also see that some days the plant really was stagnant and wasn't growing. So some days there was no significant growth with the plant. And I think, that's most of my observations, Mr. Price.
All right, so what else can we garner from this?
Okay, so based on what we have here, we can also determine the mean, the mode, and the median. And I know a lot of you at home are very familiar with these words, mean, mode, median, right? By the way, what we mean by mean? What's the mean?
What's it mean? All right, so definitely what we'll do in terms of finding the mean of this is we would add up all of these heights and divide by the number of days. So we realize we have 13. So we'll add up all of these numbers from 6.2 right down to 7.3 and then divide by 13. And that will have given us our mean. But there are some other information that we could garner from this if we move forward.
Oh, yes, we could also garner the maximum and the minimum height, which is something that we mentioned before.
Yeah, definitely.
We could also look at the range, standard deviation. So there are a variety of things that we could garner from our summary table given.
Yeah, definitely.
Okay. All right. And here it is that we have it. So the average height of the average height of the plant is 6.68 centimeters. The minimum height is 6.2 centimeters, and the maximum height is 7.3 centimeters.
Definitely.
All right.
All right, so here we have another set of raw data, right? Now, the data set below shows the number of COVID-19 cases. Well, I don't even like to mention COVID-19, right? But it is here, all right? So it is numbers in a particular community over a 23 days period. Now, here are the numbers, raw data. What can we get from this data?
Well, immediately I can see that, maybe we have a we have a mode, which is 7, but it's kind of hard to get anything from this data because it's not organized.
It's not organized.
So it is difficult to get the information because here it's raw data. It's much easier when our data is organized to then extrapolate information from the data.
Definitely.
Okay.
Definitely.
But just by looking at it, though, I see a lot of 7s. So I'm assuming that, 7 cases on one day, it seems to be the number. So we have 7 cases on several days, I'm assuming.
Right. And we're seeing also that the highest number of cases found on any given day would be, 11?
Yes, I'm also
seeing
that.
And the lowest would be 1.
Yes.
Right, so we can see that, but maybe not much more we can really ascertain from this unless we actually start analyzing it some more, grouping it, and so forth.
Okay.
All right, so here we have an activity.
Okay, so we're going to jump into our first activity for the morning. Here you're given a line graph, and it shows the monthly sales in thousands of dollars at a school cafeteria from the period January to May 2010. Okay. What type of graph is this, Mr. Price?
Well, this is a line graph.
Okay, so we're looking at a line graph, and we notice that on our y-axis, we have sales in thousands of dollars, and on our x-axis, we have the months. So we're looking at January to May. All right. Now we're asked a few questions, and I hope that you guys are paying attention at home and ready to jump in with us. So, between what 2 consecutive months was there the greatest decrease in sales? So, between what 2 consecutive months was there the greatest decrease in sales?
All right. So, based on what the question is asking, so if you realize, and this is a CSEC past question, they have bolded 2 as well as greatest to remind us that we are dealing with just 2, and then we have the word consecutive, right? What do we mean by consecutive?
One after the other, right?
One after the other.
Okay.
All right. So which 2 consecutive months were the greatest decrease in sales seen? So we are looking at in terms of the dip in terms of the line. Our word that comes to mind is slope.
Oh, okay, yes, that's true.
The slope of that line. And when we mention slope, we are thinking about gradient as well, right? But just glancing at it, we can see that greatest decrease would be between what, March and April?
Yes, it would be between March and April.
Between March and April. And if we should actually find the gradient of that, and obviously gradient is going to be a -1, right? Based on the slope of the line, the gradient is going to be a -1, which really depicts a decrease. So the gradient in this case would be negative 2.5 over 2, right? It would be negative 5 quarters. So in this period, we'll have the greatest decrease. But what is it in terms of value?
Okay. So we're going from, in March, we had what? $27,000 in sales, and in April we had $15,000 in sales.
Yeah, right.
So if we were supposed to look at it in terms of quantifying it in terms of a monetary value, that is what it would be.
Definitely.
All right. Part 2 says, calculate the mean monthly sales for the period January to May 2010.
And there we make mention of the word mean again.
Okay, right. So we talked about what it meant a little earlier. So in this case, we're going to need a few things, right? We're going to need the value of sales per month, right? So in January, I believe, so Mr. Price is going to help us out now. So in January, looking at this graph, I believe we have $38,000 in sales.
Yes.
So January, sales was $38,000. In February, we had $35,000. And in March, we had $27,000.
Yes.
In April, it went down to $15,000. And in May, it went all the way down to $10,000.
Wow.
So if we wanted to calculate the mean at home, don't do it yet, Mr. Price. Let's ask our audience. If we wanted to calculate the mean for the months January to May, how would you guys go about doing that? Quickly, write it down on a piece of paper, calculate the mean for us. just before we put up the answer. You know how it goes. We don't really want to, you know. So real quickly. All right. So Mr. Price, let's walk through it.
Yes.
So we identified the sales value a while ago. So let's see how your mental math going. So it's 38,000 plus 35,000 plus 27,000 plus 15,000 plus 10,000. What's that going to give us?
That sounds like 125,000.
No, Mr. Price, you come right out this morning. So it's 125,000.
Quiz time.
Okay, $125,000 in sales. And this was over how many months?
1, 2, 3, 4, 5 months.
So it was over 5 months. So we're going to divide 125,000 by 5. And our result will be?
25,000.
25,000. So the mean sales from January to May 2010 was $25,000.
Yeah.
I hope you guys got that at home, right?
Yeah.
So you got that 25,000. Let's look at the third question now. So the total sales for the period January to June was $150,000. So from January to June, it is $150,000. Calculate the sales in dollars for the month of June.
Yeah. Yeah.
No. You think there's any sort of relationship between part 2 and part 3?
Yeah, definitely.
Okay.
We have just ascertained that between or from January to May, right, it was $125,000. Now, when it reached to June, it reached $150,000. So it means that there was an increase there, right? But by how much?
So if the total sales from May to June was 125,000 and from January to May was 125,000 and from January to June is 150,000. Well, my maths, maybe a little bit off, but I don't think so this morning. It's just going to be $25,000 increase. So in terms of sales, there's a $25,000 increase in sales.
Definitely.
All right. So let's see if there we go.
You're on the ball.
All right. I'm going on well, all right? So, and the very last question today says, comment on how the sales in June compared with the sales in the previous 5 months.
Wow. So what we're seeing definitely is that there was an increase, right? Because it went to 125,000 in the past 5 months, then all of a sudden 150,000. So we are seeing an increase. But let us see how that increase is depicted. Right? So there we have it. So what would our comment be like? We could say there was a marked increase from May to June, and then we could quantify it and put the increase there as well.
Yes, we could. So if you notice the trend of the graph coming along, trend in sales, realize that sales kept on going down and down. But something happened in May. Maybe they changed their marketing strategy, right?
Maybe January to May was COVID.
Probably.
And then after COVID, it just spiked.
There we go. So it could have been several things. But the important thing is identifying the trend in the line and understanding what is happening, what's happening with the slope, right? And then being able to then compare what happened with the period of January to May and what happened between May and June.
Yeah, definitely.
Right?
And here again, we see the importance of a line graph, because the line graph shows what? Change over a period of time.
Yes, it does. All right. And remember, how we give our answer may vary from how you give your answer. And there's no one way as long as you identify the requisite things that the question is asking you for. All right. So I think that's it for activity 1. All right. You guys ready? We're going on now to activity 2. And I hope that you're following with us. So in activity 2, we have the heights of sample seedlings were measured to the nearest centimeter and then arranged in class intervals as shown below. Now, before we were given data that was not grouped. Now we're looking at grouped data. All right, it's getting a little bit more interesting, right?
Yes.
Okay. All right. So here with our frequency table shows group data, and it is asking us how many seedlings were in the sample, right? So just looking at this table, can we tell how many seedlings were in the sample?
Maybe not right off the bat. But, you know, with questions like these, students normally make a mistake in that they may select the largest number as it pertains to the frequency. So they may say it's 22 seedlings that were in the sample, or they may select the last number that is there, which is 14.
So this leads me to a very important question. What is frequency?
Well, the frequency is how often a particular event occurs. So, for example, in this case, a height of 3 to 7 centimeters, it is saying there are 0 seedlings that would fall in that range. While in 8 to 12 centimeters, in that band, we would have 3 plants, 3 seedlings that falls in that range. So if we are going to find how many seedlings were actually in the sample, we would have to have a sum of the frequency, which is really what we are talking about. When we talk about a summation of the frequency, which other word could we use?
Cumulative frequency?
Cumulative frequency.
Okay.
Right?
And cumulate, you know, to add up as we go over time, right?
Yeah.
As we go along.
Definitely.
So in this case, what you're saying to me is that I would have to add up all my frequencies to find the total number of seedlings in the sample.
Definitely.
All right. So in this case, we had 0 plus 3 plus 12 plus 16 plus 22 plus 18 plus 14. All right. Let's see what that would give us. So again, we spoke about the cumulative frequency. So we're going to add as we go along. So we start off with nothing. And we added 3 to that. So we have 3. We added 12 to 3. We got 15. 15 plus 16, 31. 31 plus 22, 53. 53 plus 18, 71. 71 plus 14 gives us 85. So in total, we have 85 seedlings. All right, I hope you got that. I hope you got that correct at home. All right, let's look at part B. Part B says, from the class interval written as 8 to 12, in the table above, write down 1, the lowest class limit, 2, upper class boundary, and 3, class width. Now we're looking at a whole lot of things here. Interval, limit, boundary, and width. So we have to ask you, you guys at home, you've been doing statistics. What do we mean by boundary, limit, and width? If you're on Facebook, go ahead and type it and let us know. Or on YouTube, go ahead and type it. So, the class limit.
All right, so again, here we have all of these numbers on the height in centimeter. These are in classes, right? Now, in a particular class, you have a lower limit and a upper limit. So your lower limit, obviously, would be the smaller number, right? So in the first class, for example, your lower limit would have been 3. Your upper limit would have been 7. All right, so this particular question makes reference to the class interval 8 to 12. So here then, based on what we have discussed before, the lowest class limit would have been 8, because that's the smallest number in that particular class. Now, as it pertains to boundary, what's the difference between the limit and the boundary?
Okay, so we know that most of the times we can have the upper limit of one class and the lower upper boundary of one class and the lower boundary of another class being the same, while the limits are different, right? So in terms of our class boundary for 8 to 12, it would be 12.5.
12.5.
Okay.
All right, so just simply add 0.5 to the upper limit, and that will give you your upper boundary. All right.
And the very last question asked us for the class width. What are we talking about there?
So the class width. So how many seedlings, for example, is in a particular class? So 8 to 12, for example, how many seedlings are in that class? So a height of 8, 9, 10, 11, 12. So the width of that particular class would have been 5. We could also subtract the 2 consecutive lower limits, for example. So 3 from subtract 8, 8 subtract 3 would give you 5. So we could get our answer like that as well.
Okay, And part C says to us now, copy and complete the table by inserting the midpoints of each class interval. So when we're talking about midpoints here, we are talking about midway through the class, right?
Yeah,
so if we're looking at a class from 8 to 5, we're talking about the midpoint between 8 and 5. All right? So in this case, we'd simply find our midpoint by adding our lower limit plus our upper limit and dividing by 2. Because as we say, we wanted to find out where midway between the classes.
Right.
So as you can see here, that would have been 10. So 8 plus 12 would give us 20. 20 divided by 2 is 10.
Right. And the table is partially prepared for us.
Yes.
So if I didn't remember what midpoint was, I could just look at 5. What have they done to 3 and 7 to get 5? What have they done to 8 and 12 to get 10? Right? And if I figure out that, I would realize that they have added 3 plus 7, 10, divided by 2 or half it, they get 5. So we could just continue on that trend.
Okay. So as you can see, as Mr. Price said, we just continued along the trend by adding our lower limit plus our upper limit and dividing by 2. And very last thing is the missing values for the class interval after 33 to 37. So, guys, are we noticing a trend? We know the width of the classes. So could you determine the next interval in this table? Could you determine it? All right. Let's see if you are correct. So the next interval would have been 38 to 42, because remember the class width is 5. So we could have used that to determine the next interval in our table. All right, so I hope you guys have been following with us, right?
Right, and then for a midpoint, again, we can add 38 plus 42, divide by 2, we get 40, or we could just follow the trend that is there, realize that we are just
increasing by 5 each
so
time.
Those are just all multiples of 5. But why you think this information was captured using grouped data rather than the line graph that we looked at before?
Well, this is a lot of seedlings, you know, sir.
Yeah,
it's a lot of seedlings. So can you imagine your graph with 85? I'm going to map out that on a graph with 85 seedlings?
Definitely.
No, still.
Right, and the next thing is that although we are seeing just 3 and 7, for example, for the first class, there are maybe plants that are in there that are what, like 3.1 centimeters, 3.2 centimeters. So all of that is covered in that particular class. So that is why it is important for us to have it in bands like this.
Yes, to group the data. So it's easier for us to get the information from the data that we have, right? Especially when we have a lot of data. All right. So I believe that's everything for our activity 2. So here we have activity 3. So a class of 30 students counted the number of books in their bags on a certain day. The number of books in each bag is shown below. Now, I want you guys to take a look at this question, but we're going to pause right here, right? So we'll take this quick break and we'll return with a whole lot more.
Okay, welcome back to class time. This is math, and we have been looking at discussing making inferences from statistics. So, Brittany, you were saying?
So if you're just joining us, you've missed quite a bit, but if you pay attention, I'm sure you can catch on.
Yeah.
So we were here looking at activity 3. And activity 3 looks at a class of 30 students who counted the number of books in their bags on a certain day. The number of books in each bag, and we're now asked to copy and complete a frequency table, right? So based on the number of books they had in their bags.
Yeah.
So if you notice, the maximum number of books the students had in their bags were 7. And the minimum number of books any child had in their bag is just 1. All right. So 2 persons had 1 book in their bag. 3 persons had 2 books in their bags.
So
5 persons had
Brittany,
3 books.
so what are these sticks called? What?
Those are actually known as tally marks.
Oh,
Yes.
tally marks.
You remember before when we're counting up things, you played little games at school, right?
Yeah.
And one, you
yeah.
put a stroke, you put
Yeah.
a stroke and you cross. So, yeah, man, tally marks.
Beautiful.
I know you guys remember that.
All right,
I
so
made
when
a
we
lot.
reach 5, we realize that we have 4 vertical, and then we use the 5th one to go across. So we put that in a bundle.
So we have 1 bundle of 5. So we had 3 people with 5 people with 3 books in their bags, right? And the table continues on, right? So we notice the frequency here. So if you notice, the tally column and the frequency column, they're the same thing.
They're the same thing.
Okay,
They are the
look at
same.
that. I wonder if you guys ever paid attention to that before. The question then went on to ask us to state the modal number of books in the bags of the sample students. Modal number of books. Now that is something
Modal
else
number.
that came up earlier in the lesson.
yeah.
What do we mean by mode?
Yeah. Well, that is a number that occurs most frequent. All right,
Okay.
so here we're seeing numbers of books, number of books over here from 1 to 7. On the frequency, we are seeing the numbers 2 right down to the highest number is 7. So definitely we are seeing that the modal number of books would have been 5.
Because that's the one that occurred
Yeah,
most
most
frequently.
frequent.
We had 7 people having 5
5
books
books.
in their bags. Okay. Using the table above, they also asked us to calculate the total number of books. Right. So the total number of books. Now, this is where it gets a little interesting now. We are given a few things. We're given the number of books, and we're given the frequency and tally. But I see another column.
Yeah.
I see F multiply X. What does that mean?
Well, from the table we are seeing that they are telling us that frequency is depicted by F. But where is X? Could X be my tally or the number of books?
No, sir. If X was my tally and my tally and frequency are the same things, that could not work. So X has to be the number of books that we have. So F multiply X actually means what? What are we doing there?
The frequency times the number of books.
So that's actually giving us how many. We can use this information now to get our total number of books in the sample.
Right.
All right. So we're using that information to find the total number of books. So each time we're multiplying our frequency by the number of books given in column 1. So as you can see, we have 5 people having 3 books in their bag. So in total we have 15 books. There. 24, 35, 24, 21. Now the total number of books, what would we have to do now? Are we finished there? Just leave it there?
Well, we haven't found the total as yet.
So having done F multiply X, we still need to go ahead and summate this column. So we need to sum all of these numbers.
All of those numbers.
Right? So it's 2 plus 6 plus 15 plus 24 plus 35 plus 24 plus 21. Oh gosh, Mr. Price.
That's what?
That's a lot.
127.
Oh, wow.
Yeah.
Mr. Price is very fast with the math. So let's see if you're correct, sir.
Oh, 127.
I have a feeling Mr. Price knows the answers. All right, so it's 127 books. And they also went ahead and asked us for the mean number of books per bag. And again, you see this coming up again, mean. They're asking us for the mean number of books per bag. All right.
All right, so what's the difference? We have found mean before. But in this particular problem, we are seeing that we have f times x, and we have just found the sum of f times x. So we can actually use a formula. Right? You remember that formula?
No, show us the formula, sir. Go ahead and show us the
All
formula.
right, so mean, right, and we know that we use
Yes.
bar x to pick mean. So mean is equal to the summation of fx over the summation of
f.
f.
All right. So we already know fx, the summation of fx, which is 127. And we also know summation of f, do we not?
Yeah.
So we know that it's also 30.
30.
All right, so it's 127 divided by 30.
And that would have given us...
You're sharp on the math this morning. Come, Mr. Price.
No.
That would have given us 4.23. All right, so the mean number of books per bag.
Yeah.
Number of books per bag, though.
So on an average,
we have 4 books.
they would have 4 books. Well, that is when school used to keep, when students used to have books in their bag. You remember those days?
What do you mean? Well, them have them on the table now.
When books used to be in bags.
Yes, I know. Now we have laptops and tablets.
Yeah, books are on the table and in the city and somewhere else.
Yes. So on average, though, we would write 4 books per bag. So if you notice here, we have 4.23. But we're talking about books.
Yeah.
Can we have a fraction of a book in your bag?
Yeah,
these are some things.
The cover is gone or a few leaves.
Guys, you cannot follow Mr. Price. You know Mr. Price is about the jokes this morning. We're not following Mr. Price. So on average, we have 4 books per bag. All right? Okay, the very last question now says, determine the probability that a student chosen at random has less than 4 books in his or her bag. Now the question getting really interesting. All right, probability. What is that?
Probability is just simply a chance, a possibility. How possible is it? Right?
Okay, so at random, if I pick any student in this class of 30, I want to know what is the chances of getting a student with less than 4 books in their bag.
Yeah.
All right, so how are we going to go about this one?
All right, well, in our table here, we are seeing, again, the number of books. We are seeing that the number of books less than 4 would have been 1, 2, and 3, obviously. All right, so how many students, based on our frequency now, would have had less than 4 books in their bags? That means they had either 1, 2, or 3 books.
Oh, so just by looking at the table, I can see that there will be about 10 students.
Yeah.
So just by taking this from the table, so I know when you guys saw the word probability, you probably got a little bit scared and thought it was something out of the ordinary. But just by looking and making an inference from the table, we could see that only 10 students had less than 5 books in their bags.
And then now, our attention now needs to go back to the question, how many students were in the class?
Oh, yes. 30 students.
30. And you just inform us that there are 10 students who would have had less than 4
books in their bags. Yes.
So it will be 10 out of the 30.
So you're telling me that with probability, it has to be a fractional value. Yeah. Oh, that is something. So, can it happen? Can it not happen? Yeah. If it can't happen, 0. If it definitely will happen, 1. And then everything else is in between there. So some of you might have stopped at the 10 persons because that would have caught a lot of people. But it's actually not 10 persons, but 10 divided by 30, right? So it would actually be a fractional value, which is a third.
Right.
So the probability here is actually a third.
A third.
All right. So a third of the class would not have more than 4 books in their bags. All right. Let's look at another one. So guys, we're riddled with questions, activities for you today. I hope that you're getting into the mood of things. So here we have activity 4. And now we're looking at the mass of parcels. And we have 60 parcels in total at the post office. And we have the data grouped and recorded in the histogram. So if you notice, we looked at the table before with group data, and now we're looking at a histogram.
Yeah.
All right. You're asked to use the table to complete the information from the complete the table using the information from the histogram. All right.
Question though, what is really a histogram, and how is a histogram different from a bar graph?
Okay, so just by observation, right? The bar graph, I know, has a separation. The histogram, the bars are not separated.
I wonder why. Why are they joined together? They should have social distance like the bar graph.
No, man, because we generally look at group data on the histogram, right? So we can't social distance there, right? So we're going to use the histogram to complete the table. So if you notice the relationship, for the first interval, 1 to 5, we have 4 parcels. So we have 4 parcels, 1 to 5.
Right, and we can see it right here.
It's the same thing. When we look at our histogram, it would be the same thing. They're asking us now, for the interval 16 to 20, how many parcels do we have? So we're going to our histogram, and we have to locate 16 and find out where that is, what bar would represent 16 to 20.
Right. So this would have been this one right here. Yes, 16 to 20.
And from just looking at it, it looked like that would have been 15 parcels.
Yeah.
So that would have been 15 parcels. Okay.
But looking at my table though, right, so we have seen it from our histogram, and they have asked us to use our histogram to complete the table. But could I use the table alone to reach that 15 as the answer there?
So guys, now here Mr. Price comes with a little trick and tip. So some of the times you don't necessarily have to go ahead, because we talked about cumulative frequency before. And if it is that I'm using my cumulative frequency column, there's a little trick that we could do. Mr. Price is helping you out this morning. So if you notice, as we go along, it would have been 4, and we're adding the number of parcels next to get our cumulative frequency. So 4 plus 10 gave us 14. Right. 14 plus 17 gave us 31. Now we know that 31 plus something gives us 46. Now what can I add to 31 to get 46? So that's a little...
Have to be 15.
Boy, Mr. You know you have the little tricks. You have the tricks. Mr. Price has the tricks for you. So that's something that you can also use. So guys, if you get a little nervous in the exam and you're not sure, or you want to just check back to make sure that this is actually happening, you could also use your table with your cumulative column. All right. So
that would have been 15.
The next one we have is the class with 21 to 25. And we know that number of parcels is 11. So what is our cumulative frequency?
All right. So again, we can use both methods, right? So we have 15 there. What would have been our cumulative frequency?
So I could have done one of two things. I could have just add 46 plus 11. So that's one way. Another way is that I can actually go on over to my histogram and locate the class and then identify what's the number of parcels within that class for that class.
All right.
Right. So 46 plus 11 would give us
57.
57.
Yeah. Right. And then we see the number of parcels there would have been 3, and we can see that from our histogram right there.
Or again, you can always use Mr. Price's little tidbit and help yourself out. Right. So the question continues. I thought the question finished, Mr. Price.
Not finished.
Okay.
Not finished.
So part B says, on the grid provided, using a scale of 2 centimeters to represent 5 kilograms on the x-axis and 2 centimeters to represent 10 parcels on the y-axis, draw the cumulative frequency curve for the data. No, don't worry, we're going to skip to the graph because I know you're wondering, what graph is she talking about? We're also going to use this graph from B to estimate the median mass of parcels. So these words coming back, mean, mode, median. Oh boy. All right, so here we have our curve, right? And on our y-axis, we have our cumulative frequency, as was said. And on our x-axis, we have the mass of the parcels.
I like the shape of this curve.
Yes, I like it too. It looks like a S.
Looks like a S.
Yes.
The cumulative frequency curve, does it always take on this general pattern?
Yes, it actually does. It actually does. And when it is that you're drawing this graph, it is best that you try to get a smooth curve, right? All right.
So your hands have to be steady. You know, there's a particular instrument that they use at times to sketch the curve, that French curve. You know a French curve?
Long time I don't see that.
Long time I haven't seen it. But persons use it at times, but it is not really recommended to be used. You need to use your free hand and sketch. At times you have to turn the graph paper at different angles to, you know, get those curves to the level that you want it to. But it must take on this general pattern.
Yes, it should. No, so here we have our graph, right? And the last question says to us that we're using this graph to estimate the median mass of parcels. No, I have a question for you, Mr. Price. Right, I know that I collected 60 parcels at the post office. So right there and then, I know that the middle must be 60, right?
The middle of 60 is 60.
Yeah, the middle of 60 is 30. Oh gosh, look at that.
Look at that.
Sometimes that happens too. So please, guys, pay attention.
So the middle of 60 is
30.
30. So you're saying
30 parcels.
to be 30 parcels.
Yeah, man, the median must fall
But
around there.
the question make mention of median parcels. So look at where the 30 is.
Oh, you mean the question makes mention of median mass, Mr. Price? Yes.
Parcels.
Yes.
So on your vertical axis, that's your cumulative frequency. On your horizontal axis, those are the masses for your parcels. So if you're going to give the value for that, it must be read off from your horizontal axis. That is where the masses of the parcels are depicted.
That is true. So it's important that you can identify where the middle value in terms of the number of parcels that you have. But you need to now read the mass that would be associated with this middle value. Right?
So the 30 is just the position.
The 30 is the position, but I now need to know the mass that is associated with this position. All right. So let's see. Okay, so it looks like 15 kilograms.
All right. So we identify where 30 is, which is halfway between 60. Draw a line from 30 to our curve and then down to our horizontal axis and read off the value there.
All right. All right, so here we have activity 5. So students in a group were asked to name their favorite sport. Their responses are shown on the pie chart below. So these students like football, cricket, and tennis. Boy, I don't even know if I'd be very good at any one of these. All right, so we see here that we have the angular measure. You notice that? So cricket, you know the angular measure there is 94 degrees. Tennis, 45 degrees. And football, I really just don't know. All right, so let's go dig a little deeper and see where this question is taking us.
This pie chart, though. So we have looked at the line graph. We have looked at the tally table. We have looked at the histogram. Now we are looking at the pie chart. All of these diagrams are used for different situations. Now, why do you think they chose to use a pie chart to depict the information here?
Well, for me, one thing is this is easy for me to see, I don't think, it's easy for me to just look at it and see it's 3 different categories that I have, which is football, cricket, and tennis. So easy for reading. One of the things I'm assuming that's why you can use a pie chart.
Yeah, definitely.
It's probably also not looking at any grouped anything, right? So I'm also using the pie chart because we're not looking at the grouped frequency table.
Right, and it shows really quickly that we are looking at the whole. right? So the circle is displaying the whole that we're looking at. And then we can look at the portions in which the whole is divided into. So the pie chart is beautiful for that.
Okay. That is true because, again, easy for me to read.
Easy to read.
All right, so let's take our final break. And when we come back, we'll wrap things up with this pie chart question. We'll soon come back.
Okay, thanks for sticking with us. Let's pick up where we left off. All right, so we were talking about the pie chart.
Yes,
right?
we were.
And its importance in that it shows the whole and portions in which the whole is divided. All right, so here we have the three sports. Which one is your favorite?
Well, I know I would not be good at cricket nor football. So here's what. I will work with tennis, right?
Oh, so you're in the minority.
I am good over there. Yes, sir. I'm in the minority.
All right, so right here, even before we go into the questions that will be asked, we can ascertain some information right here. So just as what I've said before, tennis, you would be in the minority.
Yes, and I can bet where you would fall.
Right.
You want me guess?
Not football.
What do you mean?
Actually, cricket.
Really?
Yeah.
So,
cricket.
sir would not be in the majority because just from looking at this pie chart here, we know that football would be the majority sport. I thought most, out there kicking ball on a Sunday.
No, the knees, when you reach a certain age, you have to preserve your knees. So I will go with the cricket.
That is definitely true. Yeah. Okay.
All right. So here we also see angles.
Yes.
Right? What is the sum of the angles in a pie chart, in a circle?
So the sum of angles in a circle is 360 degrees.
Yeah.
So all of the angles in the circle should sum to 360 degrees.
Yeah.
There's a lot of information we can get from this question.
A lot of information. So we can actually preempt some of the questions that are going to be asked. So since the sum of the angles is 360 degrees, we have a missing angle there. So obviously they're going to ask us to find that missing angle at some point.
That is certainly true. So before we even start the question, guys, you can just use your knowledge of angles, right? Angles in a circle, and know one of the questions that they're probably going to ask you, because we have X degrees. You more than likely want to know what X degrees is going to be.
Definitely.
All right.
And then again, what is the possible range for our answer? Can this angle be more than the angle for football? Could it be more than 360? Could it be less than 94?
Well, if the angles in the circle sum to 360 degrees, sir, it could never be more than 360. So it has to be less than 360. But based on what I'm seeing here, it has to be more than 94.
Definitely.
Right? Okay.
All right, so let us see what they're asking.
All right, let's jump into the question. So, look at that. The very first question is asking you for the value of X. So, quick, we can find the value of X. We know that all the angles in the pie chart sum to 360 degrees. We know that two angles one measures 94 degrees and the other measures 45 degrees. So 94 plus 45, subtract that from 360. Let's see what we got. 221 degrees. 221 degrees. All right. So angle X right there and then measures 221 degrees.
Right. So that basically proves the range in which we see that our answer would fall. It has to be more than 94, but it must be less than 360 degrees.
The question 2 says to us, what percentage of students chose cricket? So now we're going into something else. We're looking at angular measure. Now we're looking at percentage.
Right.
All right.
And here again, it's beautiful because we know that percentage is out of what? 100. So we're looking at that whole again, right? So this angle, that corresponds with students who chose cricket. We're looking at that angle as it relates to the whole, which is 360, and we're converting that to percent. So we know that we're going to be multiplying by 100.
Okay, so the fraction of persons that play cricket or chose cricket is going to be 90, in this case, it's 94 degrees divided by 360 degrees multiplied by 100. All right, look at that. So the percentage, because remember that the percentage that we're looking at is 26%. Your response should be in percentage.
All right. And then they could have asked you for the percentage as it pertains to tennis as well.
That is true.
Right. And then if you should find the percentage for cricket, for tennis, and for football, all of those should add up to 100%, because that is the whole.
Yes. All right. The third question says, given that 40 students chose tennis, calculate the total number of students in the group. So 40 students chose tennis. And we know that tennis is the minority number of persons in our sample.
Yes.
So how is it that we're now going to go about finding out how many persons we have in total? Now let's look at what it is that we know. What we know. We know that tennis is a fraction of the entire circle, and this fraction is 45 degrees divided by 360 degrees, right? What we do not know is what the total number of persons are, but we do know the number of persons that play tennis. So we can set this up. There's only one unknown in this equation, right, Mr. Price?
Yeah, definitely. Right? But before we go to the unknown, so it is 45 divided by 360, which would give us 1/8, right? So the circle would have been divided into 8 equal parts. So since one part is 40, represent 40 students, then it is 8 times 40.
There we go.
So we'll have how many in all?
We'll have 320 students in all. All right. So let us look at a little summary. A line graph commonly displays change over time. The pie chart is an appropriate means of representing percentages of a whole. Each part is represented by a slice equal to the proportion of the parts.
Right, and that's the other summary that we have looked at the frequency table when it is used. It looks at number of occurrences in a particular event, right? The tally table depicts the tally marks, and the histogram requires variables that take a continuous, it is continuous variables that we put on the histogram.
Alrighty, so that's all for today on making inferences from statistics. You can catch a repeat of today's lesson on JNN at 5 p.m. or on video on demand on One Spot Media.
And also, don't forget School Time, channel 24 Hours Learning on One Spot Media. Tune in tomorrow for CSEC English summary writing. Until then,
wash your hands regularly.
Sanitize.
And please, wear your mask. Bye-bye.
Bye.
Hi there, I'm Simon Preston from TVJ. Thank you very much for watching our YouTube channel. To see our latest videos and also to see live events, click here. To see our full videos on onespotmedia.com, click here. Thank you very much for watching.